Yes,
Right,
sir.
now we're going to be looking at ease of ionization. Now, it's a bit different as it relates to, it's not the, whenever you look at the atomic radius and the electron shells, right, for group 2 and group 7, right, the properties are similar. However, as it relates to ease of ionization for group 2 and group 7, right, they are not similar, they are very much different. And the reason being, right, remember the, hold on, give me a minute. Let me see what's this thing or the font size. All right, good. So the reason being, remember that groups two would be metals are non-metal.
Sir, group how much?
Group two,
Metals, sir. Yeah, metals, sir.
good. Right, and remember that we say metals do what again? Metals lose or metals gain.
Repeat, sir.
As it relates to electrons, right, metals gain or lose.
Lose, sir.
Good, excellent. Right? And we already mentioned the properties, the ease of ionization for the alkaline earth metals in our previous session. Right? Now, as it relates to non-metals gain electrons, right? Even though we already write that down, I'm just gonna put it on the side here. So with reference to electrons, right, you have metals lose, non-metals gain. Now, as it relates to the ease of ionization, right? The ease of ionization refers to the ability for the atom to form ion. I already mentioned that, right? That is what we mean by ease of ionization. We're gonna write it back again in the sticky note over here. In a nutshell, right? It's basically how easily an atom form or turn ion. Right? So ease of ionization refers to the ability for an atom to turn ion, right? How easily does the atom turn ion? Right? So it refers to how easily an atom turns to or can be converted to ion. Now, ease of ionization as it relates to group 7, right? The halogens, right? Ease of ionization increases as you move up the group. So moving up the group, ease of ionization increases. I'm going to explain why in a few. Just write it over here. So ease of ionization increases when you go up the group. All right. And the reason being is because, right, as you move up the group, right, the outer shell is closer to the nucleus, right? So the idea is that remember that the pull from the nucleus, right? It's easier now when you move up the group. It's easier for the nucleus to get a pull from the outer shell of another electron, right? Electron shell of another atom. I'm gonna draw it and explain to you. Right? So let's go back to what we have here, the structure for both fluorine and chlorine. All right, so here's a no Morgan, right? Still following, right?
Yes.
All right, good. So if we're supposed to compare these two elements, right, where you have fluorine and chlorine, right? As it relates to fluorine, right, the outer shell is closer to the nucleus than the outer shell of chlorine. So remember that when the outer shell is closer to the nucleus, right, there's a greater pull on the outer shell by the nucleus. So it's easier now, being that there's a greater pull on these outer electrons that you see the arrow pointing on. Whenever another atom want to also form ion, it's easier for this compound to basically react with that atom, right? You understand what I'm saying, or I have to explain over?
Sir.
Morgan, you get to me just say a while ago, or I have to explain over?
Sir, yeah. It kind of break up, sir.
All right. So the outer shell that you're seeing here, there is always a pull. If it is that the outer shell is closer to the nucleus, there's a greater pull on the outer shell once it's closer to the nucleus. The closer it is to the nucleus, the greater the pull on the outer shell by the nucleus. So it's easier now for this compound to gain an electron, being that there's a greater amount of pull, or there's greater amount of pull on the outer shell. Right, so the outer shell is close to the nucleus, so it's easy for it to gain an electron, right, from another atom when that atom ionizes. So you have greater nuclear force on the outer shell here, and the outer shell that you see in the arrow pointing, versus this chlorine here. Reason being because the chlorine, remember that there's an extra electron shell added to the chlorine structure. So as you move further away from the nucleus, right, the pull or the nuclear force reduces.
Sir, so the increase going down, sir.
Is of ionization will increase going down. As it relates to group 7, increases as you go up the group.
Yes, sir.
Remember that non-metals gain electron, right? And the reason why they want to gain electrons, right? You remember that for you to gain electron, there has to be some form of bonding, right? And bonding is as it relates to forces, right? You have nuclear force, electrostatic force, right? That therefore mean this element, right, or this atom here would be very, very reactive, right? So that therefore mean it's easy for it to gain an electron from a metal per se, if the metal loses electron, because there's a greater amount of pull by the nucleus in the overall structure here. The overall structure would be very reactive. It'd want to gain electron. You get that?
Yes, sir. Sir, write it down.
Yes, man, definitely. Everything that we do, we write it down, man.
Finish, sir.
So the last one that we'll be looking at for today's session, right, would be reactivity. Right, and we just want to know as it relates to once the ease of the direction at which the ease of ionization increases, the reactivity would also increase. So would reactivity increase up the group, or would it increase down the group? What do you think?
Down.
Yeah, increase down the group. Remember, they want to gain electron,
Oh, up, sir.
So reactivity increases up the group as well. So reactivity increases.
Up the groups.
And again, remember that the idea is that the elements, the outer shell, is closer to the nucleus, right? So there's a greater as it relates to the whole nuclear electrostatic force within that compound, within not that compound, within that atom. It would be highly reactive. You definitely want to gain an extra electron to have a full outer shell. You get that?
Yes, sir.
Good. So reactivity increases up the group, right? Ease of ionization also increases up the group.
Yes, sir.
However, as it relates to electron shells and what else? Electron shells and the atomic radius, the atomic radii, those increase when you're going down the group.
Yes, sir.
So, any questions, any queries? I get what we did. You understand everything that we have completed for today's session?
Yes, sir.